In a hospital care facility, the number of transfer switches required for emergency, legally required, and optional standby systems depends on several factors. Let's examine each system individually. For an emergency standby system, which is legally required, generally one transfer switch is necessary. This transfer switch connects the emergency generator to the vital electrical systems, ensuring power is available during outages for critical functions like life support, lighting, and communication. For an optional standby system, the number of transfer switches is dictated by how many non-vital systems are intended to be backed up by a standby generator. Each non-vital system that requires backup power will typically need its own transfer switch. These systems might include things like convenience outlets, some HVAC equipment, or non-essential lighting. A legally required standby system's transfer switch requirements vary by jurisdiction. For example, NFPA 99 healthcare facilities generally requires one transfer switch for the emergency electrical system to supply essential and life safety loads. Optional transfer switches may be used for backup of non-essential systems. Therefore, the minimum number of transfer switches needed for a hospital care facility with an emergency, legally required, and optional standby system includes one emergency transfer switch and one optional transfer switch, if desired. This results in a total minimum of 2 transfer switches. Remember that additional optional transfer switches can be installed to provide backup power to other non-essential systems depending on the facility's specific needs and priorities. Therefore, in summary, firstly, an emergency system, which is legally mandated, typically necessitates one transfer switch to link the emergency generator to essential electrical systems. Secondly, an optional standby system requires a transfer switch for each non-vital system intended for backup power via a standby generator. Thirdly, a legally mandated standby system has transfer switch requirements that vary based on local regulations. For instance, NFPA 99 usually mandates one transfer switch for the emergency electrical system to power life safety and essential loads. Additional transfer switches can be used for backing up non-essential systems if needed. In practical application, consider the different types of loads and their power requirements. Life safety loads, such as emergency lighting, fire alarm systems, and critical medical equipment, must be connected to the emergency power system through a dedicated transfer switch. This ensures that these vital systems remain operational during a power outage. Critical branch loads, which include equipment essential for patient care and treatment, also need to be connected to the emergency power system. A separate transfer switch may be used for these loads, depending on the facility's design and the requirements of the local authorities. Equipment branch loads, which are less critical but still important for the operation of the hospital, can be connected to either the emergency power system or the optional standby system. The choice depends on the specific needs of the facility and the availability of backup power. Optional standby loads, such as convenience outlets, non-essential lighting, and some HVAC equipment, are typically connected to the optional standby system through their own transfer switches. This allows the facility to maintain some level of comfort and convenience during a power outage. In addition to the number of transfer switches, it is also important to consider the type of transfer switches used. Automatic transfer switches are typically used for emergency and legally required standby systems, as they automatically switch to backup power when a power outage occurs. Manual transfer switches can be used for optional standby systems, but they require someone to manually switch to backup power. The size of the transfer switches must also be appropriate for the loads they are serving. Transfer switches are rated in amps and volts, and the rating must be sufficient to handle the maximum current and voltage of the loads connected to them. It is also important to consider the coordination of the transfer switches with other electrical equipment in the facility. The transfer switches must be coordinated with the overcurrent protection devices, such as circuit breakers and fuses, to ensure that the electrical system is protected from faults and overloads. Transfer switches must also be coordinated with the generators to ensure that the generators can supply the necessary power during a power outage. Regular testing and maintenance of the transfer switches are essential to ensure that they are functioning properly. Transfer switches should be tested at least annually, and any necessary repairs or replacements should be made promptly. Proper maintenance will help to ensure that the transfer switches will operate reliably when needed. When selecting transfer switches, consider the following factors. Firstly, load requirements. Determine the total load in amps that the transfer switch will need to handle. Consider both continuous and inrush currents of the connected equipment. Secondly, voltage and phase. Ensure the transfer switch is rated for the correct voltage and phase configuration of the electrical system. Common voltages in healthcare facilities include 120/240 volts single phase, 208 volts three phase, 277/480 volts three phase, among others. Thirdly, transfer switch type. Decide between automatic and manual transfer switches. Automatic transfer switches provide seamless power transfer during outages, which is crucial for critical healthcare applications. Manual transfer switches are typically used for less critical loads. Fourthly, open vs. closed transition. Open transition transfer switches momentarily interrupt power during transfer, while closed transition transfer switches provide a brief overlap of power sources. Closed transition is preferable for sensitive equipment that cannot tolerate power interruptions, but may require synchronization capabilities and is generally more expensive. Fifthly, codes and standards. Ensure that the transfer switches meet all applicable codes and standards such as NFPA 70, National Electrical Code, NFPA 99, Healthcare Facilities Code, and UL 1008, Standard for Transfer Switch Equipment. Sixthly, reliability and durability. Choose transfer switches from reputable manufacturers known for producing reliable and durable equipment. Consider the expected lifespan and maintenance requirements of the transfer switches. Seventhly, monitoring and control. Some transfer switches offer advanced monitoring and control features, such as remote monitoring, data logging, and communication capabilities. These features can be helpful for managing and maintaining the electrical system. Eighthly, ease of installation and maintenance. Select transfer switches that are easy to install and maintain. Consider factors such as accessibility of components, availability of spare parts, and the manufacturer's technical support. Ninthly, cost. Compare the cost of different transfer switches, taking into account factors such as initial purchase price, installation costs, and maintenance expenses. Choose transfer switches that offer the best value for the specific application. Tenthly, future expansion. Consider the potential for future expansion of the electrical system when selecting transfer switches. Choose transfer switches that can accommodate future load growth. In summary, the selection of transfer switches for hospital care facility requires careful consideration of various factors, including load requirements, voltage and phase, transfer switch type, codes and standards, reliability, monitoring and control, ease of installation and maintenance, cost, and future expansion. By carefully evaluating these factors, it is possible to select transfer switches that will provide reliable and safe backup power for the facility's critical loads. Remember that legally required standby systems vary by jurisdiction, and you must consult and adhere to those regulations. One must always refer to the latest editions of NFPA 70 and NFPA 99, as well as local and state codes for specific requirements related to transfer switches and emergency power systems in healthcare facilities. Properly installed and maintained transfer switches are critical components of a reliable emergency power system. Let's delve into specific considerations for legally required standby systems and how jurisdictions impact the number of transfer switches required. Firstly, NFPA 99 is a widely adopted standard for healthcare facilities, but local jurisdictions may have amendments or additions. Check with your local authority having jurisdiction or AHA to verify if there are any specific local requirements that supersede or supplement NFPA 99. Secondly, essential electrical systems in healthcare facilities are typically divided into two branches: life safety and critical equipment. Life safety branch supplies power to lighting, fire detection, and alarm systems. Critical equipment branch supplies power to equipment necessary for patient care such as operating room lighting, select receptacles in intensive care units, and cardiac monitoring equipment. Jurisdictions might require separate transfer switches for each branch or allow a single transfer switch to serve both branches. Thirdly, some jurisdictions may mandate additional transfer switches for specific critical loads beyond those covered by NFPA 99. Examples include backup power for specific medical equipment, data centers, or communication systems. Fourthly, consider the generator sizing and capacity. The number and size of transfer switches must be coordinated with the generator's capacity to ensure adequate power is available to all connected loads during an outage. Fifthly, coordination studies. A coordination study should be performed to ensure that the transfer switches and other overcurrent protection devices are properly coordinated to minimize disruptions during faults. Sixthly, regular testing and maintenance. Jurisdictions typically have requirements for regular testing and maintenance of emergency power systems, including transfer switches. Adhere to these requirements to maintain system reliability. Seventhly, documentation. Maintain detailed documentation of the emergency power system, including transfer switch specifications, wiring diagrams, and test results. This documentation will be helpful for inspections and future maintenance. Eighthly, consult with qualified professionals. Engage with qualified electrical engineers, contractors, and consultants experienced in healthcare facility electrical systems to ensure compliance with all applicable codes and standards. Ninthly, consider the impact of future expansions or renovations. Plan for potential future expansions or renovations of the healthcare facility and ensure that the emergency power system, including transfer switches, can accommodate the increased load. Tenthly, be aware of changes in codes and standards. Codes and standards for healthcare facilities are regularly updated. Stay informed of any changes that may impact the emergency power system. Remember that optional standby systems give flexibility, allowing you to choose which non-essential loads to support during an outage. Consider the impact of an outage on various non-essential systems when deciding how many optional transfer switches you need. Some hospitals might choose to back up certain HVAC systems to maintain patient comfort or specific administrative functions to ensure business continuity. The number of optional transfer switches depends entirely on the facility's specific requirements and risk tolerance. In summary, determining the correct number of transfer switches involves understanding emergency systems, legally required systems which are jurisdiction dependent, and optional systems which are use case dependent.